Alright guys, this is a chronograph I've been working on. Chronograph measures the speed of a projectile. I'm going to be measuring the speed of a pellet gun. So I 3D printed this, and this V shape clamps onto the barrel of the gun to align it to shoot through this speed sensor. And what this speed sensor is on the bottom. It's got two infrared emitters pointing upward at the bottom, and then it's got two infrared detectors pointing downward at the top. And as the projectile goes through, it will break the infrared between the first set of emitter detector, and it will start timing for the time it takes to break the first set of detector and the second set, which are 2 inches apart. And then I can use that in the code to calculate the feet per second. And I did that. So I 3D printed this with the infrared detector and emitters, and then I wanted something faster than an Arduino, so I used a STM blue pill, which I've messed with these before and had them laying around, but I really don't use them much. I usually use Arduino, but in this case I needed faster speeds, and this is a 72 megahertz, and besides that, I put well, that's voltage regulator, because my initial plan was, instead of using one single detector pair for the front and one single detector pair for the back, my initial design had 5 on the front and 5 on the back, and I just had too much problems of the infrared crossing over between the sensors, and you had to basically put your fingers over all the sensors to block anything. You know, it was too much infrared in there and all that, and that's why I put I don't know if you can see really, but I put all these extra holes, was to help prevent infrared from bouncing around and ricocheting around and making the sensors not work correctly. So I went from 5 to just 1 on each side, and with this alignment thing, it'll actually break the sensors anyways, because it'll be nice and lined up. So with this STM32 blue pill, and then I have an LM339 voltage comparator, and I got this potentiometer there to set the voltage it's comparing to, because these sensors, these photo transistors, they'll put out some high voltage, but if it's something that's super quick or just barely catches the edge, it puts out a lower voltage. So I've got the voltage comparator set up to where if it gets more than what was it, 50 milliamps, then it will trigger high. And the only problem I had with using this STM32 was I did not realize that you can't just use the B3 and the B4 pins. They have something to do with the debugging output, and they don't normally work as regular pins without changing something about the debugging. Yeah, I didn't realize that, and I've had a lot of headaches for a day, not sure what the problem was, and it turned out to be, oh well, you can't just use those pins without doing something else. So I just moved them. I just moved it to different pins after I learned that. So basically, it's doing a digital read, and the The voltage comparator is making anything high that's over 50 milliamps, and it's doing a digital read. And yeah, let's try it out. So we're going to drop some BBs through here, and here's the code. Wait, is this the right code? Yeah, this is the right code. So I seen something on the internet and I like the way they did it. They took while the digital read equals 0, just do a continuous loop. So while nothing's broke the infrared sensor, it's just going to loop indefinitely. But when something does break the infrared sensor, it's going to move on in the code. And that's when it's going to measure the time. And then it goes into another infinite loop until the back sensor is broke, and then it's going to move forward from there and reset everything and keep the values. So I've just been getting this done, so I don't have it all done real nice yet. I'm waiting on screens to come in, so I don't have an LCD screen, but we're going to drop some BBs down here, if I can do this with one hand. If I hold it like that, I can do it with one hand. So it might take a couple tries because it's got to be nice and aligned to actually break the sensors. Okay. Alright, drop the BB. And if we look, it said that was 3 feet per second. It's a real simple math equation. Feet per second equals 1,000,000 microseconds. So yeah, and since it's only 2 inches, we're going to multiply the time it took to go 2 inches by 6 to get a foot. And then and that's the milliseconds it takes to go a foot. And you divide that into 1,000,000, and that gets your feet per second. So yeah. Oh, let me see if I can drop another one into here. That one didn't trigger. But you get the point. Yeah, I can't do this with one hand, but yeah, you just get your simple infrared triggers, go into a fast microcontroller, and it measures the milliseconds and it converts it into feet per second. And then I've got I 3D printed this battery holder, and I got an on-off switch. And once I get LCDs in the mail, I'm going to put an LCD to show the output instead of just doing it by serial. But yeah, that's a little project I made. Took a couple revisions, and yeah, it's I'm going to try it out today on an actual gun. I haven't tried it out on a gun yet, but just dropping stuff through it seems to work just fine, you know. So yeah, that's my little chronograph project. Alright, later.